Have you ever looked up at the stars and wondered what it would be like to float among them? To live in space, it's a dream for many, but what does it actually do to your body? The reality is far more extreme than you might imagine. Let's blast off and explore the science of how the human body changes in space. The moment you escape Earth's gravity, your body starts to react. First, you'll feel something called space adaptation sickness. Imagine the worst motion sickness you've ever had, and you're getting close. About half of all astronauts experience this. Your inner ear, which tells you which way is up, gets completely confused without gravity. This conflict between what your eyes see and what your inner ear feels can lead to nausea, dizziness, and headaches. It usually lasts for a few days until your brain adapts to this new, topsy-turvy world. While your brain is recalibrating, a major fluid shift is happening inside you. On Earth, gravity pulls your bodily fluids down towards your legs and feet. In space, without that pull, fluids rush upwards into your chest and head. This is why you see astronauts with puffy faces and skinny chicken legs. It's not just a cosmetic change. This fluid shift tricks your body into thinking it has too much water, so your kidneys kick into overdrive and you start flushing out liquids. You actually become slightly dehydrated. This shift also increases pressure inside your skull, which can affect your vision over long missions, a condition astronauts call space fog, but the biggest long-term challenges are to your muscles and bones. Here on Earth, every step you take, every time you lift something, you're working against gravity. This constant resistance keeps your muscles strong and your bones dense. In the weightlessness of space, your body doesn't have to work as hard. Your muscles, especially the large ones in your legs and back that support your posture, start to atrophy or waste away. Astronauts can lose up to 20% of their muscle mass in just a couple of weeks if they do and exercise rigorously. The same thing happens to your bones. Your body is incredibly efficient. If it thinks your skeleton isn't needed to support weight, it starts to break down bone tissue faster than it builds it. Astronauts can lose bone density at a rate of about 1 to 2% per month. To put that in perspective, an elderly person on Earth with osteoporosis loses about that much in a whole year. This makes bones more brittle and increases the risk of fractures, especially upon returning to Earth's gravity. This is why you see astronauts spending hours every day exercising on the International Space Station. They use special equipment like treadmills with harnesses that strap them down and resistance machines that create artificial tension to simulate weightlifting. It's not just to stay fit, it's a crucial medical countermeasure to fight muscle and bone loss. Without it, a long-duration mission to Mars, for example, would be almost impossible. Your cardiovascular system also gets a bit lazy. Your heart doesn't have to pump blood as forcefully against gravity, so it can actually shrink in size and become weaker over time. When astronauts return to Earth, their hearts have to suddenly work much harder again, which can lead to feeling faint or dizzy as their bodies struggle to readapt to gravity. It's a condition called orthostatic intolerance, and we can't forget about radiation. Earth's magnetic field and atmosphere protect us from most of the harmful cosmic radiation that zips through space. Astronauts don't have that full protection. They are exposed to much higher levels of radiation, which can damage DNA and increase the long-term risk of cancer. This is one of the biggest hurdles for planning long-term missions, like a multi-year trip to Mars. Scientists are constantly working on better shielding for spacecraft and potential medical treatments to mitigate this risk. Even your immune system seems to get a little confused in space. Some immune cells become less active, while others become overactive. This strange imbalance could make astronauts more susceptible to infections or cause dormant viruses in their bodies to reactivate. Scientists are still trying to understand the full implications of this, but it highlights just how finely tuned our bodies are to life on Earth and what happens when they come home. The readaptation can be just as challenging as the initial adaptation. Astronauts often need physical therapy to regain their muscle strength, bone density, and balance. Simple things like walking can feel strange and difficult at first. Their bodies have to completely relearn how to live with gravity. It can take months or even longer for those who have been in space for a year or more to feel normal again. So while floating in space looks like effortless fun, it's a constant battle for the human body. Every system, from your bones and muscles to your heart and immune system, is pushed to its limits. The research being done on astronauts is not just about keeping them safe. It's teaching us incredible things about human physiology, aging, and diseases like osteoporosis right here on Earth. It's a testament to human resilience and our unyielding drive to explore the unknown, no matter the cost to our own bodies. The next time you see footage of an astronaut gracefully floating inside a space station, remember the incredible biological journey they are on. It's one of the most extreme environments a human can experience, and every day in space is a scientific experiment in itself. Thanks for watching, and if you found this journey into space biology fascinating, make sure to like, subscribe, and hit that notification bell for more deep dives into the wonders of science. See you next time.